Welcome again in the next session of application of derivatives in the field of economics. And in this session, I will explain you the how you will prove that there is a relationship between elasticity of demand, average revenue, and marginal revenue. So you can see here that there is a question in front of you in which we have to find out elasticity of demand when P is x e bar minus x, right? And the second part is that we have to prove that ND, that is elasticity of demand, is equals to average revenue upon average revenue minus marginal revenue. So there are two parts in this question. First of all, we will find out the value of elasticity of demand, right? So if you remember, the formula for elasticity of demand is minus P by Q into dq by dp, right? So here you will see in the question that q is not given, so instead of q we will take x, because x is taken as a substitute of q. I have already told you that in some questions the value of q is given, and in some question the value of p is given, right? So this is my formula for elasticity of demand. So first of all, what we will do, as we know that P is given, P here is price. So what we will do, we will calculate the derivative of P, right? Derivative of price. So if we have to calculate it, what we will do, we will take this equation, that is derivative of x into e power minus x with respect to x. So you can see here that there are two variables, that is into ex, and we will apply the product rule here because the sign of multiplication is there. So whenever we go for product rule, what we get, that is derivative of x with respect derivative of p with respect to x is equals to x into derivative of e power minus x plus e power minus x into derivative of x, right? So when we have to take the derivative of e power minus x, it gives me, if you remember the binomial theorem, this shows that e power minus x plus log of e and plus derivative of minus x, that is derivative of power, and it is in negative. We have minus x, so we will take here minus x. So and we know that log e is equals to 1 and derivative of minus x is equals to minus 1. So this gives me e minus e power minus x as the value. So if I put this value here, I will get x into minus e power minus x plus e power minus x, and derivative of x is equals to 1. So we get finally e minus x into e power minus x plus e power minus x. And if you see here, this e power minus x is common in both the values. So what I will do, I will take this as common. So it gives me minus x plus 1. Now this is the value of dp by dx. But if you see here, we need the value of dx by dp. So what we will do, we will take the reciprocal of dp by dx, right? So I will get dx by dp. This is equals to 1 upon e power minus x plus 1, right? So this is the value of dx by dp. Further, in order to calculate the elasticity of demand, the formula is minus p by q, and the value of p is given in the question, that is x into e power minus x. It is divided by x, right? Because it is given in the question that it is q, but we will substitute q with x, okay? So this value, multiply it with derivative of dx by dp, that is 1 upon e power minus x into minus x plus 1, right? So in the next step, what we will get, it is minus e power minus x divided by e power minus x into minus x plus 1, right? And if we cancel this e power minus x, we are left with minus 1 divided by minus x plus 1. Or if we take minus 1 as a common from denominator, I will get minus 1 plus x, which is equals to 1 upon x minus 1, right? If I cancel this thing. So this is the value of elasticity of demand. So this is my first part which I have to prove. Now moving toward the second part, we have to prove that elasticity of demand is equals to AR upon AR minus MR, this part. So for this, first of all, we have to calculate the average revenue, and we all know that average revenue is equals to price, and the value of price here is x into e power minus x. And next we have to calculate the value of marginal revenue MR, which is equals to derivative of total revenue. But in the question, total revenue is not given. So first of all, we have to calculate the total revenue, which is equals to product into price into quality, P into Q. So the value of P is x into e power minus x, and the value of Q is x, and it will gives me x square into e power minus x. Now taking the derivative for marginal revenue of you can say total revenue, that is x square, this is sign of equals to, into e power minus x. So we will apply here product rule because the sign of multiplication is there between the two variables. It will give me x square into derivative of e power minus x plus e power minus x into derivative of x square. So as I have already told you, the derivative of e power minus x is minus e power minus x, and derivative of x square is equals to 2x. So this gives me minus x square into e power minus x plus e power minus x into 2x. Now this e power minus x is common in both the variables, so I will take it as a common, e power minus x into minus x square plus 2x. Now again from here we will take one x common. So I will get x into e power minus x minus x plus 2. Now this is the value of my marginal revenue. Now putting the values in the formula, that is elasticity of demand is equals to average revenue upon average revenue minus marginal revenue. I will get average revenue, that is x into e power minus x divided by average revenue, that is x into e power minus x minus the value of marginal revenue, that is x into e power minus x plus 2, right? So taking x power e power minus x as common, I will get x into e power minus x divided by x into e power minus x into 1 plus x minus 2. Okay, so I will cancel this, and ultimately I am left with 1 upon x minus 1. Now you can see here the value of elasticity of demand is also 1 upon x minus 1, and here if we prove that elasticity of demand is equals to AR upon AR minus MR, so this is also equals to 1 upon x minus 1 upon x minus 1, right? So we have proved this thing that these both, when we apply this formula, that is of average revenue and marginal revenue, or we simply calculate elasticity of demand with the formula, that is minus p upon q divided by dp by dq, we will get same results, right? So this we have to prove and hence verified. I hope the concept is clear to you. Thank you.